same way as between this user and the machine, between them. So we must consider of what kind is this interaction. We already said that we have two dimensions, sensor and effector, from the user to the machine and conversely. And in physical system, we have to consider two variables. For example, displacement and forces. So the first concept of Cadoz and NIME is this notion of connection point. So M connection point when we output a position and input a force, and conversely the L position, the L connection. So an object in Cadoz and NIME language is a set of smaller object communicating with this kind of interaction. And finally, the language is based on two basic atoms, which are called material element and liaison, link element, which are the smallest we can introduce in order to get first a very simple language and second a very general system. And Cadoz and NIME object is in fact a network with which nodes are mass or material element and arcs link or liaison element. And on this basic element we developed a set of mechanical algorithm with a specific approach in order to obtain a very optimized algorithm. So, for example, the mass for a controlled material element, particle, a spring, a damper, and etc. Just a few words about simulators. In fact, the real-time situation is very important. But what is real-time? It's not only the fact that we must get the responses in the same time as the action, but in certain synchronous conditions. It's very important. And in fact, the first real-time experiment on TGR was made with an analogic calculator by Jean Florent. And our first synchronous simulation software was implemented in a digital equipment LAC11 in this year. And in fact, it was very slow. That is, it was a very, very small sampling rate, but in fact, it was really real time. And at this time, in 1982, we built, Tallinn Berberian in our laboratory, built a first dedicated computer processor, the Cadoz temps réel, CTR, which was probably the first in the world, I don't know, physical modeling simulator in real time. With this processor, we were able to simulate a string, for example, with 40 masses. We replaced it by a floating point system array processor, AP120, and during the 19th, we replaced this by silicon graphics workstation that are a good compromise between graphic quality, powerful speed of calculation, and Unix with a Unix environment. And the next is what we are doing now, but I cannot say anymore on this. As a first step, we can consider deeply that we have, in fact, three domains: physical modeling, force feedback transducer, and this concept of multisensory simulation. And all these three things are not separate, in fact. Just now, I would like to show you some experiment made during the 18th. For example, this marionette from Annie-Luciani in 1984, which was simulated with the AP120 and in real time, and manipulated by its feet thanks to these two joysticks with, in this situation, for the moment, no force feedback. there was some little problem with the video projection. In fact, it's more... Okay. And this is the very first multi-sensory simulation. It's not very good, but in fact we have in this example a real combination in real time with between force feedback, visualization and production of sound. This is a kind of tennis racket moving horizontally, manipulated by the K, and acting on a small ball that struck walls that can sound. Which is a maracas with a set of particles in a box. We manipulate the box and move that makes the particles moving, and we perceive in the finger the striking of the particles on the box. Okay, and now this first real-time bowed string with a displacement sensor and a force sensor from John Florent in 1986, but not with force feedback.
Of a bowed string. The string is simulated in the same way as before. Here again, the sound and the image of the string are displayed in simultaneously with the gestural action of the instrumentalist. The difference is found in the mode and the means used to excite the string, here with the bow action.
C'est-à-dire le système manipulé par l'instrumentiste. Ce dernier est une espèce
The bow is an electromechanical unit composed of a displacement sensor to show the relative bow position to the string and a force sensor that acts on the pressure put on the string by the bow.
Va nous permettre d'agir sur la pression exercée par l'archet sur la corde. Si je n'appuie pas sur ce capteur, je ne mets pas la corde en vibration.
When this sensor is pressed while displacing the bow, the string is excited to vibration. When it is released, the string vibrates freely.
Okay, so sound is not very good, it's a very old example. And this bicycle, which is also an example of interaction with gesture, in fact, we rotate the wheel that make moving the legs, not the contrary. But the video projection is seconded, but I think you can understand. Okay. Just now, more recent using of physical modeling, both for image and sound. This is an extract of a piece we made in this is a first example of, also example of image animation from animation, with Cadoz animal language.